Welcome back. So 5-6 is going to mark the end of chapter 5. I've split this into 2 days for us to make sure that we're really getting good at the things that we're doing in it. So there's two kind of big ideas. One is kind of a mini idea, and then the rest of it is all going to be kind of the big idea of this whole chapter. What has this all been building towards? The first idea is called the rational root theorem. The rational root theorem says that any possible rational root of a polynomial will be the factors of the constant term divided by the factors of the leading coefficient. Or more visually is this. So basically this is a way of finding any possible rational root. It's not saying everything on the list is a rational root. It's saying these are the only possible ones. So what does that mean? Well, it means we need to take the factors of 2. So the factors of 2 are 1 and 2. Notice I'm including negatives because negatives are technically factors of numbers as well. Factors of 5 are just 1 and 5. And now it says that the only possible factors come from those. So factors of the constant, so factors of the 5 means I need to take the 1 and divide it by 1. Take the 1, divide it by 2. Now take the 5 and divide it by 1. Take the 5 and divide it by 2. So take everything in the list of the factors of the constant, divide it by everything in the list of the factors of the leading coefficient. So here this means I have 8 possible rational zeros, rational solutions. Now, again, I emphasize the idea that they are just the possible ones because in this instance, if you notice, when you actually calculate each of those, that's the only one that actually is a rational zero, okay, a rational solution. So keep that in mind that this list is not saying that they are all of the solutions, okay? It's saying that those are the only possible solutions, and now you have a starting point of where you can check. So, if I want to know the possible rational roots of these following polynomials, the first thing I need to find out their factors. So here, 1 and 3 are the only thing that divide 3. And here with the 8, 1, 2, 4, and 8. So you need to list out those factors, and now you need to make your list, dividing all of those factors of 8 by all of those factors of 3. So for example, I'm going to take 1 divided by 1 and the 1 divided by 3. I'm going to take the 2 divided by 1 and the 2 divided by 3. The 4 divided by 1 and the 4 divided by the 3. The 8 divided by 1 and the 8 divided by 3. And so that list is a list of if there is a rational root to the polynomial, it must be one of those values, one of those numbers. For the next one, so here factors of 2 are just 1 and 2. Factors of negative 10 are just 1, 2, 5, and 10. And now let's start dividing them. 1 divided by 1 and the 1 divided by 2. 2 divided by 1, but now 2 divided by 2 it just equals 1, which is already on my list. So I don't have to list it twice because it's already there, okay? So I'm going to bypass doing the 2 divided by 2. again, simply because 1 is already on my list. 5 divided by 1, 5 divided by 2, 10 divided by 1, and now 10 divided by 2 is 5, and 5 is already on my list, so I don't have to show it again, okay? So here, this list is an all-encompassing list of the possible rational roots of those polynomials. All right, so again, this is ideal for if you don't have a calculator and you're trying to find the solutions. This just gives you a good starting point, okay? I'm going to show you a different method to ease the process when you are searching for all of the possible or for all of the zeros, all right? Now, in discussing all of the possible zeros, okay, so that leads into the other theorem that we're going to approach today, the fundamental theorem of calculus, or of algebra, sorry. Now, I've already alluded to this in class quite a bit, but what it says is the degree of the polynomial means that it has exactly that many solutions. All right, so what does that mean? Well, what that means is here I have 3 different quadratics. So this has 2 real solutions, 2 visible solutions. This one has 1 real solution, but the trick there is it has a multiplicity of 2. So that one solution is being represented twice. So that's how it's kind of counting as 2 solutions. Okay. This last one has no real solutions because it's 2 imaginary solutions. So between some combinations of real multiplicities and imaginaries, you always have as many solutions as the degree of the polynomial. Okay, and that's going to help us because it's going to tell us how many solutions we're looking for the rest of this section. Okay, now what do I mean by that? Well, what I mean by that is now we're in a transition into finding all roots of polynomials. Okay. Now, what that means is, first of all, you should have in mind how many solutions are you looking for, okay? That's what the fundamental theorem says, okay? So just look at the degree so you know how many solutions you're ultimately trying to find. Use a graphing calculator to identify a rational root, okay? And then we're going to use synthetic division, okay? We're going to use synthetic division, that synthetic process, to pull that root out. Now, the polynomial you have left, if it's quadratic, now you use one of your various methods to solve that quadratic. So let's talk through what I mean. Okay, so if my directions are simply find all of the zeros of this polynomial. Well, to help me find all the zeros, if I'm going to use this process, I need to find one of them. Okay, to find that one, I'm going to need my graphing calculator. Okay, I'm going to type that function in to my graphing calculator. So x to the third minus x squared plus 6x, oh, sorry, plus 6x minus 6. I'm going to put that into my graphing calculator, and I'm going to use it to identify a solution. So here, I can use this to identify one is a solution, okay? The number 1 is a solution to this problem. By solution, again, x-intercept, which I did mention yesterday in the notes. So now I have one of my solutions, okay? I've identified one of the solutions. And now what I'm going to do is I'm going to use synthetic division to pull that solution out, okay? So let's use the synthetic process here. I know 1 is a solution. So now let's use synthetic division to pull it out, okay? So since I know it's a solution, I'm hoping that you can recognize what you should be getting, okay? You should know that you're getting a 0 at the end because you already knew going into it that it was a solution of this polynomial, okay? So I have a remainder of 0, constant of 6, that's my x squared. So essentially what I have here is I have x squared, no x's, but I have a 6. Now remember that solution or getting a remainder of 0. Getting a remainder of 0 meant actually this was kind of a fancy factoring problem, right? So what does that mean? Well, it means if 1 is a solution, remember it means x minus 1 is a factor. So it factored that out and left me with that. Okay, so the neat thing is synthetic division actually factored this polynomial for me. Okay, I can use it as kind of a factoring tool. So obviously from over here, you know x equals 1 is a solution. Okay, we need to figure out that other piece. Now that it's factored, now we need to know what makes that other piece equal to 0. All right, well, this other piece equaling 0 means I could subtract the 6. I can square root it. When I square root, I get plus or minus. Keep in mind, I'm square rooting a negative, so square rooting a negative means I get an I. Then there's really nothing I can do with the square root of 6. That can't simplify at all. Now, here I have my 3 solutions. 1 here, the 1, and then my plus and a minus gives me 2 more. Now you should like what you see, okay? Because look at the graph. How many solutions are you seeing? Well, you're seeing only one solution. So it should make sense to you why the other 2 solutions are imaginary, because you're not seeing them. Okay, so you can use it as a good check because I can visually only see one number cross or one x-intercept. It means my other 2 solutions must be imaginary. Okay, so keep them in the back of your mind. You have those tools to help you check to make sure you've got a good answer. I knew I should be getting imaginary because I only saw one x-intercept. So that tells me that those are my 3 solutions and I am done with this problem. So let's do another one, okay? So this is another cubic. So I know I'm looking for 3 solutions ultimately. And to begin this process, okay, I'm just going to type it into the calculator. I need one solution to get me started. So I go back into into y equals, and now I'm going to put in my new function, x to the third plus 2x squared minus 13x minus 26. All right, so looking at this, so I see 3 x-intercepts right now, okay? Now, I ultimately only need one of them to get me started on this process. So you may be wondering, how do I know which one I want? Okay, well, you only want ones that are crossing at nice values. What I mean by that is this one. This x-intercept is crossing nicely at x equals -2. These ones right here are crossing in between. So we're not sure what those numbers are, so we can't really use them, okay? So when you're going through this process, make sure you're only identifying one that is crossing at a nice value. This one is crossing at -2, so that is the solution that I'm going to start with, okay? So I know I have a solution of -2, so I'm going to use synthetic division to kind of factor that out of my polynomial. So line up my coefficients. Now let's go through this process. Pull down the 1, multiply, add, multiply. Oh, I'm sorry. Multiplying by 0 will actually just make that 0. I apologize. Or add, multiply, add. I knew I should get that 0 as my remainder because I knew going in that this was already an x-intercept. This was already a solution. And now I say this is my constant. Here's my x. Here's my x squared. So the polynomial I have left, I have an x squared, no x's, and a -13. Now remember, we've already talked about this a couple times, that when the remainder is 0, basically the synthetic division is being used to factor out that solution. So if my solution was -2, it meant it was pulling out its factor, x plus 2. And what is left behind? Well, the x squared minus 13. So really what I'm doing here is I'm using this as a factoring tool, okay? I'm going to say that over and over again to make sure you really understand what that's doing for us, okay? Every time I get a remainder of 0, basically this is a tool for factoring. Obviously, you already knew what solution that one was giving you. That is why we pulled that number out. But now we need to know the other factor. We need to know what makes this other factor equal to 0. Because remember, each factor is producing a solution when it equals 0. So here I add over the 13, square root. Whenever you square root, you've got a plus or minus. And there's nothing we can do with the square root of 13, so we just have to leave it. The nice thing here is, once again, this makes sense. I got two real solutions. Real solutions should be visible in the graph, and they are. This right here is positive square root of 13. This right here is negative square root of 13. So again, when you're getting real solutions, they are visible as x-intercepts. So this makes sense to us, okay? We got what we needed. We have 3 real solutions, just 2 of them weren't rational, so they weren't easy to find graphically. All right, so again, that's the power of this process. It's really easy to take measures along the way to kind of check to make sure that you're doing it right. So let's do our last example for the day. So again, it's cubic, so we know we're looking for 3 solutions. Now let's go type it in the calculator to see what we're getting. Okay, I'm going to get rid of those. So x cubed minus 2x squared minus x minus 6. All right, so here I'm seeing one real solution, okay? And that solution is at the number 3. So right away, based on the conversation we've had already, you should be able to communicate to me that the other 2 solutions are going to be imaginary, okay? You should already have that in the back of your mind because you're only seeing one solution. You know that there's going to be 3 total, all right? And the first solution is the number 3. So I'm going to take that number 3 and I'm going to pull it out. I'm going to kind of factor it out using that synthetic division. 1x cubed, negative 2x squared, negative 1x, and negative 6. Pull down the first number, multiply, add, multiply, add, multiply, add, And I did get exactly what I wanted, right? I knew I should get a 0 there because I knew that I was dealing with a solution. Okay, so that means this is my constant, this is my x, that's my x squared. So I know I'm working with x squared plus x plus 2. Since I got a remainder of 3, that means that this was actually a factoring tool, right? It meant it was pulling out the factor that gave me a solution of 3. So it factored that out to leave this behind. Okay, so once again, this process, when you're getting these remainders of 0, these are a factoring tool. Obviously, this first one gives you a solution of 3, right? You already knew that. But now the other one, I need to figure out what makes this other factor equal to 0, because that'll give me my other two solutions, which again, going into this, I already know are imaginary, okay? I already know because I can't see them graphically. Now this time square rooting like we did on the first two isn't going to help me, okay? That's not how I'm going to get through this. This time we're going to need the quadratic formula to finish solving this, okay? So quadratic formula, negative b plus or minus b squared minus 4 times a times c all over 2 times a. First thing I always simplify is the inside of the square root. 1 minus 8 gives me a negative 7. Now here I never ever want to leave a negative inside a square root because we know what a negative inside the square root, we know what it means. It means I'm getting something imaginary, okay? Which again makes me happy because I can't see them as x-intercepts. I know those solutions should be imaginary, again, because I cannot actually see them. So I have my two solutions from there, the one solution I pulled out at the very beginning, so I have all three of my solutions. So I know this is a lot to take in. It's actually probably my favorite section of the chapter because it really shows in the build that we've been doing to get to this point. But I know it's a lot to take in, which is why I'm making it 2 days for you. So take a moment to reflect on this, okay? Write that summary for me, and then come back ready to do some work on this, to do the worksheet so you can start exploring for yourself how to do this process.